Hola pre-calc. So today we're going to talk about graphs of tangent function. We've talked about sine and cosine, and now we're going to look at tangent. Just like we did when we did sine and cosine, we're going to start by making the xy table, and we're going to look at tan x. We're only going to talk about the key values of tangent. So if you remember, that's 0, and you should be thinking, what's the tangent of 0? And go, 0, good. And then we're going to look at pi over 4. Remember, we love the pi over 4s. Tangent of pi over 4 is 1. Pi over 2. All right, tangent sine over cosine. Something funky happens at pi over 2 because cosine 0 can't divide by 0. That's actually undefined. Continuing around our unit circle, 3 pi over 4 gives us -1. Pi gives us 0 again. 3 pi over 2 gives us that undefined. And back to 2 pi gives us 0. Okay, so we're going to graph all the way out to 2 pi because that's what we had on our XY table. All right, so we have some key things going on here. First of all, I'm going to plot my zeros. That's a nice, easy thing to plot. Point and point. Okay, so what's happening at the pi over 2's? It says undefined, but how do I represent that on a graph? Did you say asymptote? You should have. That's going to create a vertical asymptote right there and right there. So then let's think about, okay, pi over 4 is going to be in between 0 and pi over 2, and that's going to be 1. So I'm going to plot that point like right here-ish. Okay, and then 3 pi over 4 is going to be between pi over 2 and pi, and that's actually -1, and I'll make that down here. So I'll make this -1 and this 1. But what's happening as our graph goes around is tangent is going to get bigger. In fact, it's going to go up towards infinity. And then from pi, it'll go down. And then we can say up, because at 5 pi over 4, it's 1. And at 7 pi over 4, it's -1. So this is our basic graph of tangent. So now I'm going to talk to you, and we're going to point out all of the key features, just like we do for sine and cosine. Amplitude. Remember, the definition of amplitude is 1/2 the absolute value of the max minus the min. So what's the maximum? There is none. What's the minimum? There is none. It just keeps going. So therefore, there is no amplitude. None. Tangent will never have any amplitude. So let's look at the range. Well, how far down to how far up does it go? The range is all real numbers. So you can write the funky R, or you can say -infinity to infinity. They both represent the same thing. Okay? Now, tangent in this case also has to talk about the period. The period is different. You're going to say it's 2 pi. It's not 2 pi. We graphed the 2 pi, but if you look at one full cycle, that's just this one curve, like right here. That's one cycle. Well, that went from pi over 2 to 3 pi over 2, or a period is just pi. In fact, for tangent, the period's always pi divided by b. And you remember b from the general form we've talked about. So for this one, it's pi. So typically, it would just be this part going up and this part going down. If I only said to graph one cycle, the graph would stop here. Okay, and you wouldn't have to show this. However, we tend to always graph 2 cycles of tangent so you can see the full curve that's happening in the middle right here. Okay, now, what else do we have to discuss? Zeros. Remember, zeros are x values, so we say x equals. You always list the first 0 plus k distance between them. So in this case, it's 0 plus k pi. The other thing that is happening with the tangent function is now we have asymptotes. And when you have asymptotes, we need to bring in the equation that can represent the asymptotes. This is also an x value, because the x equals is what gives us the vertical line. Well, the asymptote occurs at pi over 2, 3 pi over 2. So I can say pi over 2 plus k pi. And again, that would be KEJ for both the zeros and the asymptotes. So that's the general tangent graph, and that's what it's going to look like. Let's do another example. All right, let's look at y equals 2 tan 2x. Okay, no more xy table. I'm going to go down the list. Let's talk about our amplitude. What's our amplitude? None. Right, none. Just write none, NA, whatever works. Range. Our range is all real numbers. We can say y is in the set of all real numbers. You can just do all real numbers. You could do negative infinity to infinity. The period in this case is pi divided by b, or pi over 2. All right, zeros and asymptotes we're going to come back to after we graph our function. All right, let's graph. Here's what I'm going to say with tangent. If you remember when we did sine or cosine, we talked about the whole 0, 0, 0, up, down. Right, or up, 0, down, 0, up for cosine. And that was the way to remember it. With tangent, if you double your period and go out to pi, and then you have pi over 2 in the middle, and that would make these guys pi over 4, okay? You don't even really need to label your y-axis. That's okay. But with tangent, your zeros are always going to occur at your endpoints and your midpoint. And your asymptotes are going to occur at these quarter points here. And as long as there's not a negative in front, it's going to go up. It's going to go up there, down here, and down here. Be careful when you're graphing the tangent that it doesn't look like a straight line. Okay, once we have the graph done, now we can go ahead and talk about the zeros. Well, in this case, it's x equals, what's the first zero? 0, right, plus k distance between them, so we can actually just say k pi over 2 KEJ. And the asymptote is x equals the first asymptote, which for us is pi over 4, plus k pi over 2 as well, where k is an integer. Note, when you're dealing with tangent, asymptotes and zeros should have the same k distance going on right there. That should be the same value. One, they're going to have different starting points, but it should be the same distance between them if we did it properly. Okay, if you have questions, jot them down, bring them to class. We can certainly talk about it when I see you. All right, let's do one more. All right, let's go y equals the tangent of pi over 3x. Okay, amplitude. What do you tell me? Oh, wait, you know what? Actually, why don't you pause it, try this one as a you do, and then come back and restart the video and continue and check your answers. Okay? See you in a bit. All right, so our amplitude is none. Our period is pi divided by b, which becomes 3. Our range is all real numbers. We'll bring back in our zeros and our asymptotes once we graph. Okay, with tangent, again, I like to go out 2 cycles because then I get to see a full graph. So when I do that, my marks are here. I know, again, my asymptotes are at the quarter points going on here. Our endpoints and the midpoint are the zeros. And tangent is up, up, and right here. Do not cross the asymptotes, okay? You have to be careful. It is a curve, okay? It almost looks like a cubic function, but it's a curve, not a straight line, and it approaches the asymptotes. All right, zeros. X equals 3k. Asymptotes, x equals 3/2 plus 3k, and both of these where k is an integer. Okay, hopefully we're feeling a little good with tangent, not changing up or anything. No shifting yet. All I want you doing is practicing the basic graph of tangent, changing the period, and making sure you get the zeros and the asymptotes. So here's what I want you to do. 4 problems for homework, which you may be able to knock them out in class as you're watching this video. But I want you to do 1. Please graph the tangent of 1/2 x. 2, I want you to graph negative 1/3 tan x. 3 tan 3x. And 4, the tangent of pi over 2x. All right, have a great day, and I'll see you next class.